Right now, as you design your next building, it is releasing hundreds of tons of carbon dioxide into the atmosphere. A staggering 39% of global carbon emissions. That is the footprint left by the architecture and construction industry. Governments worldwide are accelerating carbon pricing mechanisms, and the construction sector is squarely in the crosshairs. In the European Union, carbon prices have already surpassed €65 per ton. Carbon border adjustment mechanisms are spreading to new markets. For a single large project, new carbon liabilities could add hundreds of thousands of dollars to the final budget. So what choices do we have? Today, we dig deep into how AI technology can meaningfully reduce the carbon footprint of architects and interior designers, with strategies you can put into practice on your very next project. Let's confront the numbers directly. According to the International Energy Agency, buildings account for approximately 21% of global energy-related CO2 emissions, and that figure climbs further when embodied carbon from materials and construction processes is included. Consider a mid-size office building of around 3,000 square meters. From raw material production through to final construction, the embodied carbon for a project of this scale averages approximately 2,400 metric tons. At today's prevailing carbon price of roughly $30 per ton, already the reality across multiple compliance markets globally, that translates to around $72,000 in direct carbon costs for a single project. Analysts project carbon prices will reach $100 per ton by 2030, in line with IPCC pathway recommendations, pushing that same building's carbon liability to $240,000. In some markets, the carbon bill could soon exceed the design fee itself. Carbon is no longer an environmental footnote. It is now a line item in your project cost plan. The single most powerful moment to reduce carbon is at the design stage. Cutting carbon after construction is complete costs up to 10 times more than addressing it in the design phase. AI-powered lifecycle assessment automation tools are solving this problem head-on. First, BIM integrated plugins like Tally and One-Click LCA automatically read material data directly from Revit models and calculate carbon emissions in real time. No manual data entry required. Second, Autodesk Forma simulates both energy performance and carbon impact simultaneously during the early massing phase, surfacing optimal design alternatives before a single structural decision is locked in. Third, a growing ecosystem of regional LCA platforms now integrates local material supply chain databases, enabling project-specific carbon calculations tailored to construction markets in different parts of the world. What all these tools share is a remarkable capability. Life cycle assessments that once demanded days of manual calculation can now be completed in just a few hours. Material selection is the most direct lever designers have over embodied carbon, yet with tens of thousands of building products on the market, comparing the carbon footprint of each one was practically impossible until AI broke down that barrier. Here is the 4-step workflow. Step 1. Connect to an EPD database. The Embodied Carbon in Construction Calculator, EC3, gives you free access to environmental product declaration data for materials from suppliers worldwide. Step 2. Receive AI-powered low-carbon alternatives. Input the materials specified in your design and receive automatic recommendations for equivalent performance. Lower carbon substitutes with side-by-side comparisons. Step 3. Simultaneous cost and carbon optimization. AI runs hundreds of scenarios to identify material combinations that minimize carbon without exceeding your budget. Step 4. Automated reporting. Generate carbon reduction plans ready for submission to clients, permitting authorities, or ESG procurement teams in just a few clicks. Real-world projects applying this complete workflow have demonstrated an average embodied carbon reduction of approximately 23%. Reducing carbon at the design stage is essential, but it is only half the battle. Without tracking actual carbon emissions during construction and comparing them against the project plan, your carbon strategy remains nothing more than numbers on paper. AI-powered site carbon monitoring solutions are now emerging to close exactly that gap. IoT sensors mounted on heavy machinery capture real-time fuel consumption data, which AI converts directly into carbon emission figures with no manual logging. Cross-referencing material delivery records with EPD data enables cumulative material-by-material carbon tracking across the full duration of the build. Leading global contractors have already piloted these systems on major projects, reporting construction phase carbon reductions of up to 15% compared to conventional unmonitored operations. For smaller practices and projects, mobile carbon logging applications now offer an accessible entry point to real-time site carbon tracking, putting this capability within reach of firms at every scale. Treating carbon reduction purely as regulatory compliance means leaving significant money on the table. The carbon data you manage and verify with AI can be converted into real, measurable financial returns. First, green building certification premiums. AI-generated carbon analysis data significantly accelerate certification under globally recognized frameworks including LEED and BREEAM. Certified buildings command rental premiums averaging 7% and asset value premiums of up to 11% compared to non-certified equivalents, a gap that institutional investors and corporate tenants are increasingly willing to pay for. Second, carbon credit revenue. When a project's verified emissions fall below its established target, surplus carbon credits can be sold on voluntary or compliance carbon markets operating across the globe. Third, ESG procurement competitiveness. Large corporations and public sector clients are rapidly making carbon reduction documentation a prerequisite for contract award. AI-driven carbon management capability is becoming a decisive competitive differentiator in winning the highest value projects in any market. Let us bring it all together. The era of carbon pricing in construction has already arrived, and it is accelerating in every major market. But AI technology is placing the tools to turn this challenge into a lasting competitive advantage directly in your hands. Lifecycle assessment automation at the design stage. AI-powered low-carbon material selection, real-time carbon monitoring across the construction site, and the systematic conversion of carbon data into measurable financial returns. The common thread running through every one of these strategies is a single, fundamental shift in how we think. Treating carbon as the fifth core material in your design toolkit, sitting alongside structure, finishes, building systems, and landscape. If your practice is preparing a proposal for the next project right now, there is just one question worth asking.